Today we're going to be talking about direct variation. By the end of this video, you should be able to analyze a relation to determine whether a direct variation exists. You should be able to determine the constant of variation, and you should be able to represent direct variation both algebraically and graphically. First, direct variation is a relationship between two variables, x and y, such that y equals k times x. This is super important. That is the format that all of our equations will be in for direct variation. Direct variation could use different variables other than x and y. For example, m varies directly with n would be written m equals k times n. One clue is that when it says m varies, that means you are going to have m equals. The constant of variation, which is sometimes called the constant of proportionality, is the number that relates the two variables. That means that this is k in our equation. It is also the slope of the line if you graph it. If you remember back to what we did earlier this year, we talked about graphing y equals mx plus b. M was our slope and b was our y-intercept. Y equals k times x is similar to this equation, except b is 0, and instead of using the letter m for the slope, we have the letter k. So if we graph direct variation, we will have a straight line with a y-intercept of 0. That means the line will go through the point 0, 0. Let's look at a few examples. First, we want to know if each of these equations represents direct variation. If it does, we need to say what our constant of variation, or what k, is. So if we look at our first example, we have y equals 1/2 x. We need to ask ourselves, is this in the same format as y equals kx? We have y equals 1/2 x, so yes, this is direct variation. And our k value is 1/2. For the second one, this does not look like direct variation, but we need to be careful. You need to make sure that your equation is in y equals format before you can decide if it is direct variation or not. So if I solve this so it's y equals, I need to add 5x to both sides. So I have y equals 5x. Now, this does look like direct variation. And my k value is 5. For the third example, we have y equals x divided by 8. Now, this one's a little bit tricky because 1x divided by 8 is the same thing as 1/8 times x. So this one is direct variation as well. It's just a little bit harder to see. And our k value is 1/8. For the fourth one, we have y equals 8 divided by x. You might think that, like the third problem, we can rewrite this so that it looks like direct variation. but we cannot, and that is because we are dividing by x. This is actually inverse variation, which we will talk about next class. So no, this is not direct variation because we are dividing by x. The last one, we have y equals 3x minus 1. This is also not direct variation because we are subtracting 1. Anytime you are adding or subtracting a value so that your b is not 0, it is not direct variation. Another way you might see problems is using a table. So we want to know, do the tables represent direct variation? And if they do, what is the constant of variation and what is the equation? So before we look at these examples, I want to take a look at the equation y equals kx. And I want to solve it so that I have k equals. So I'm going to divide by x on both sides so that I have k equals y divided by x. I'm going to use this so that I can find the k value for each of these tables and decide if it's direct variation or not. So I'm going to make an extra column for k, and I'm going to do y divided by x. 2 divided by 1 gives me 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 18 divided by 9 is 2. Since we have the same number for k each time, that means, yes, this is direct variation. Our k value is 2, so our equation will be y equals 2x. If we look at the second one, we're going to do the same thing. I'm going to make another column for k, and I'm going to do y divided by x. 24 divided by 1 is 24. 12 divided by 2 is 6. 8 divided by 3 is 8/3. 6 divided by 4 is 3/2. Since we have a different number for k each time, that means this is not direct variation. So we cannot write down our k value and we cannot write an equation. If we look at these graphs, we want to figure out which graphs represent direct variation. For those that are direct variation, what is k and what is our equation? So as I said earlier, the graph of a direct variation will be a straight line with a y-intercept of 0. All of these are straight lines, so let's look at what the y-intercepts are. The y-intercept of our first one is 0, so that means that this is direct variation. The y-intercept of our second one is -1, so it is not direct variation. The y-intercept of our third graph is 2, so it is not direct variation. And the y-intercept of our fourth graph is 0, so it is direct variation. So now for the first and the fourth graph, we need to figure out what k is. To do that, we need to find the slope of the line, and that will give us k. So I need a second point on the line. If you think back to what we did earlier in the year, this line is decreasing, so we know that our slope is going to be a negative number. Then we look for the vertical change, which is 2, and then the horizontal change, which is 1. So our slope is just -2/1, or -2. When we write our equation, we have y equals -2x. If we look at the fourth one, We find our second point on the line. This line is increasing, so we know that our slope is going to be positive. We look at the vertical change first, and then the horizontal change. So we go up 1 and over 2, so our slope is 1/2. That means our equation is y equals 1/2 times x. Next, we're going to take a look at some problems that involve a lot of words. My suggestion for working through these problems is to first read through the whole problem, then go back, and the second time you read it, stop every time there is a period or a comma. You can generally do something with each part of the sentence. So first, let me read the problem. If y varies directly with x, and the constant of variation is -6, write an equation that represents this relationship. I'm going to go back and stop every time there's a comma or a period. If y varies directly with x, this statement, y varies directly with x, tells us what our equation is going to look like. So we have y equals kx. Then we can keep reading. The constant of variation is -6. Remember that constant of variation is another way of saying k. So we know that k is -6. Then if we keep reading, we want to write an equation to represent this relationship. We know that we have y equals k times x. We know that k is -6. So our equation is just y equals -6x. Here we're going to use the same technique. I'm going to read the whole problem. If h varies directly with p and h equals 12 when p equals 4, what is the constant of variation? Now I'm going to go back and stop each time there's a comma or a period. If h varies directly with p, h varies directly with p means that our equation is going to be h equals k times p. If we keep reading, we know that h is 12 when p is 4. So we can go ahead and plug 12 in for h and 4 in for p. And I'm going to leave k. The last part says, what is the constant of variation? Remember that constant of variation is k. So I need to solve this equation for k. So I just need to divide by 4, and I get that k equals 3. And that's it for part A. Part B says, using your constant of variation from part A, write an equation that relates h to p. So I'm going to go back. Using your constant of variation from part A. Remember that constant of variation is k, and in part A we learned that k equals 3. If we keep reading, we want to write an equation. So I'm just going to plug in 3 for k. I have h equals 3p. And that's my equation. Problem number 6 says, if a varies directly with b and a equals 15 when b equals -3, find the value of a when b equals 8. So if I start reading again, I have a varies directly with b. I can go ahead and write out my equation. A equals kb. The next part says a is 15 when b is -3. So I can plug those in. And again, I still have a k in my equation. The last part of the sentence says find the value of a when b equals 8. We're not ready to do that yet. Even though it does not specifically ask us to, we need to solve for k and write our equation. So to solve for k, I need to divide both sides by -3 and then write my equation. So my equation is a equals -5b. I just take my value for k and plug it back into the equation that I wrote in red. Now I can go ahead and read the last part of my question. Find the value of a when b equals 8. So I know that b is 8. So I'm going to plug that in. And I need to figure out what a is. Well, if I just multiply this, I end up with a equals -40. And that is my final answer. So, even when it does not specifically ask for it, you will need to find k and probably the equation to answer these questions. Lastly, let's look at a word problem. Again, I'm going to read the whole problem and then I'll go back and look at it in detail. Jose is making cupcakes for the French Club. The number of cupcakes Jose can bake varies directly to the number of hours he spends baking. If he can bake 60 cupcakes in 2 hours, how many cupcakes can he bake in 5 hours? So if I go back, if I read the first sentence, Jose is making cupcakes for the French Club. That doesn't tell me anything about my equation. That's just the background part of the story for this problem. So I don't care about that. The next part of the problem says, the number of cupcakes Jose can bake varies directly to the number of hours he spends baking. Here you see the words varies directly, so we can figure out our equation from this sentence. In previous problems, it always said y varies directly with x, or h varies directly with p, or it gave us some variables. Here it doesn't. But we know that the number of cupcakes varies directly with the number of hours. So I'm going to use c for cupcakes and h for hours. So my equation will be c equals kh. Let's keep reading. If he can bake 60 cupcakes in 2 hours, this means that c is going to be 60 and h is going to be 2. Now I'm going to go ahead and solve for k. So I divide by 2 and I get that k is 30. So if I write my equation, I have c equals 30h. And if I read the last part, I want to know how many cupcakes can he bake in 5 hours. So I know that h is 5. So if I plug that in, I want to know how many cupcakes that would be. So 30 times 5 is 150. Since this is a word problem, we want to make sure that we accurately answer the question. So he can bake 150 cupcakes. And that's it.